Hey, good morning. Good
Hi,
morning,
morning.
Professor Merland. How are you?
I'm good. How are you?
Good, good, thank you. Would it be possible to for me to share my screen? Um,
Oh yeah, of course. Yeah, I already tried to share my screen just to see if the setup worked. Do you see my screen now? Do you see a presentation?
yes, right now I'm seeing your screen.
Um,
Because what I would like to do is to introduce the topic and to introduce you,
yeah,
and then you will have the floor, as we mentioned before.
yeah, sure. No, then I'll just as a test so that I know
Fantastic. Thank you so much.
now it's gone, right? Yeah.
Yes, right. If I'm sharing mine. Good morning, students.
Morning.
Good morning.
Right, can you see my screen with the big table of stage one's conferences?
Yes, it's
I can see your
visible.
screen. Yeah, sorry. Yeah, I
Yes,
can see your
right,
screen. Yeah.
right. Right, great. So students, make sure that you have the update version. I just put it in the on the Canvas platform. We have a little change. We may have a change on February 20th because this conference has still to be confirmed. But we have all two other confirmation. Um, we have the one on the 23rd, which is confirmed with Dr. Asma Mewdui from ISISCO, and we have the other one from Franklin Wagner, and it is scheduled for February 27 at 8 p.m. at 8 a.m. Sorry, not 10 p.m. Right. We will give us still a few minutes after 8 a.m. in order to get a chance to have everyone joining us. Very glad to see your faces, students. You know how much we appreciate it. And yes, we have, it's a great way to know you right before Paris and before the teams. Right? Other types of information that I could share. I will share your team role next Monday. And I suppose that we will have a meeting on the 40th in order for me to explain to you what are the expectations, because we will change from stage one to stage two. So it will be the right time to see you and give you some details about the role assignment.
May I ask, out of curiosity, are most students from the US, or in which
No,
time
no, no,
zone?
no, no, no. We have, and look, I can show you the map. We
Okay.
have students coming from 18 universities, so this is the reason why I'm so appreciative of you setting this conference on at the beginning of the afternoon in European time in order to fit all the different time zones. Yes, we have students
Nice.
coming
No,
from
good to see.
different universities around the world. And so they have not met each other yet. We are for the moment working on Zoom online, and we will meet in 3Ds, as we say, in Paris on March 22nd.
Nice. Okay, good to know. Yeah, thanks.
Yeah. Good morning, everyone. Good morning, Ruda, Aurélie, Antoine,
Good morning. Hi.
Manisha, Audrey, Bernardo,
Good
Thomas.
morning, Mom.
Good morning.
Camille, Aparna, Anaël, Ria. Did I say it right? Ria? Is that the right way of
Yes,
Good,
that's
nice, good.
so
What
I
is that?
have this up on a screen, so I'll be turned towards this. I hope that's fine.
Great. I don't know if Fernando is with us, but we do not have AI note takers during these meetings. Good morning, Emmanuel.
Hi, everyone.
Vera, good morning. Anna?
Yeah.
Great. It's so nice to see your faces. Right. Still a minute. Olivier, good
Excuse
morning. Good afternoon.
excuse me, ma'am.
Yes.
Ma'am, I just wanted to know, like, the previous meeting recording, will it be shared with us?
So, I mean, this is a question I have the recording, but I share it with the one who have explained to me why they were missing, right? So I took note of your email. I will answer it today.
Okay, thank
Good.
you.
Great. Right,
Can I
Olivier,
point out,
Camille. Yes, Ria?
excuse me, can I point out even our first speaker, I think, was named Thomas. So, sir, we're very happy to have you today. It is a fun coincidence.
I'm sorry, I don't get it.
Our first speaker for conference one, his name was Thomas as well, his first name,
Is the
I
first
believe.
for the first conference, his name was Thomas Klein.
Yes. And
Yeah.
sir's name today is Thomas as well. I thought that was a fun
both,
Oh,
coincidence.
nice. Okay,
both Thomas, yes.
right. Great. Yes, and did you see the news about um, the India AI Summit, right? That you have the possibility to attend some of the sessions made for the youth and with the GPAI. So this is wonderful. We are so happy, so glad to have this possibility. If you can connect, I know that it is Indian time. So for the one who are in a different time zones, it might be difficult. But if you have the opportunity, please do that and join us for this time. This is unique, and it may be a good way also for you to have a sense of the international relations set up for and the agenda, right? So glad to have you this morning. Thank you, everyone. We are very glad to welcome Professor Morland this morning with us, or this afternoon, or tonight. For some of you, Eve, I didn't greet you. It's so nice to have you as well. Matthews, Samia, this is nice. Emmerich, thank you so much for being there. For the one who don't have the camera yet, please open your cameras. This is, a way to connect, to know more about each other. As we said, and I will go back to this, please note that we have some changes in the big table of the Zoom conferences. So especially regarding the international organization, I am not sure that Claire Stark will be able to make it on February the 20th. But we have Dr. Asma Meudiewi from UCESCO who is doing it. So we are so happy to have her. She will do it, and she will do the conference on March 23rd, which is a Monday. So make sure that this is in your plan. I updated the Canvas platform about it, and so we're good to go. I would like to welcome you as we normally do for these conferences, and to give you some update regarding also the ways we are working. We are working in the Chatham House rule, meaning that with this management and this consideration, we want you to have the camera open at all times to create interaction with the full attention which is required, no phone use, no multitasking, and focus on the conferences. No recording. So for the one who has right now an AI note taker, please put it back and close it. We don't want to have AI note takers for these conferences. Thank you for your understanding. And no recording of any kind is allowed. Thank you for not sharing on social media, except when we have the authorization of our speakers. Great. So we have today students coming from all these different countries, and I'm so glad to see your faces and this map. Students coming from Emory University in the States, the University of Florida, Georgia State University, Université du Québec à Montréal in Canada, Université du Québec at Rimouski in Canada, Polytechnic Montreal, Canada, Federal University of Santa Catarina, Brazil. Great to see you again this morning. University of Nairobi. I hope you have joined us. I've not greet you yet, but I hope you're with us. Al Baraimi, University College of Oman. Thank you for being here with us. I saw you this morning. Carunia University, thank you for being there. Presidential University, thank you for you being there. Institut Catholique de Paris, ICEP, meaning Engineering School for Digital Affairs or Digital in Paris, France. Great to see you on board. Université de Tours, France, and University de Florence, Italy, Leiden University, and International Digital Dialogues Fellowship programs from Germany. So glad to have you on board. This is so nice. So this morning we are welcoming Professor Thomas Morland from LIAX, Leiden University. And it's a great pleasure to have you. It's just Professor just opened and published a new book, and I think we will speak about it. Professor Morland is an assistant professor in the Computer Science Institute of Leiden University in the Netherlands. He graduated from medicine and mathematics, after which he pursued a PhD in AI at TU Delft. His research focus on machine learning, in particular reinforcement learning, where computers learn through the reward and the punishment with the trial and errors. After his PhD, he returned to Leiden University, where he now co-leads the reinforcement learning group. And next to his technical research, he's also interested in the bigger picture of AI and how it relates to our own brain and thinking, partially including his medical background. To this end, last year he wrote a popular scientific book, and I will let him say the title because it's in Dutch, on the inner workings of modern AI, the similarities and the differences with our own thinking, potential for a future for both in co-intelligence. He will tell us more about it. Professor Morland, it's a pleasure to have you with us today. Thank you so much for your time and your dedication to the students. What we will do is that I will open the floor and give you the floor. If you you will do your presentation, and then we will open a Q&A session with the students who have prepared some questions for you.
Great, thanks so much. Then I will share my screen. So just to check, can you now see my presentation screen with the title From IQ to AI?
Yes.
Yes, okay, all good. Well, then I'll get going. This is indeed the title of the talk. Also, it was also the title of this book. Was just mentioned. So I'll talk today to you mostly about AI, but also relating it.
Sorry.
I can only see the Zoom page right now.
Yes, we are seeing your Zoom page, the join meeting, the white blank page.
Ah, okay.
Not the slides.
Not the slides. Okay, well, that's Surprising. And now do you see anything, or is it still?
It's still the join the meeting Zoom page.
Okay, because I am sharing a screen. Let me see. And now is it still a white screen or not?
Just a minute. We see that it's coming. Still waiting.
It just shows a black screen so far. We can see your mouse, but we cannot see anything else.
That's very surprising. Okay, let me try another one. Because I'm just choosing to share my desktop. What else? And now?
Now we see Slack.
We see Slack.
You see
I
Slack.
think we see Slack.
Yeah, well, that's the only one I can pick from the list, actually. It's very weird.
Is it possible to share the entire computer screen and then you just choose your presentation and then you share it full screen?
Yeah, so that's what so the options I have is to share desktop 1, desktop 2, whiteboard, Slack, or Zoom for Workspace, but I don't have the presentation itself or my entire screen, weird enough. That's very surprising. How can I get out of this? I just only have the options that doesn't actually show. I thought if I share desktop 1 or 2, you would see it, but apparently that would be my entire screen. Wait, let me quickly unpack my second screen and see whether that matters. No, now the. Okay, if I'll sign 1 second, I'll sign out of Zoom and sign back in, okay? Just to
Right.
check whether
Thank you.
it might
Thank
be
you so much.
sometimes a bug.
Yeah. In the meantime, it's a way for me to greet Marcel, Abdul Rahman, Samia, Emric, Iman, Ashuman, Fabrizio, Andrea, the one I've not, Intisar. Thank you for joining us, Intisar. Great. Adam, we don't see your face. Matthews neither. Sarah, Karim. Right.
Yeah, the weird thing is that it doesn't catch my presentation view.
Why?
Okay.
Do you want to send it to me? And I
Yeah,
can.
maybe that's enough already.
Yeah.
I don't know why this is actually not showing.
Right. Do you want to put
Yes.
it in the chat or send it to me?
Yeah, I'm sending it to you now. I can also put it in the chat.
Right. Okay. Questions about technology?
Yeah, it's always also attach it to that.
Right.
Now also uploading in the chat. There's not certain permissions you can give me extra, right? In the settings of sharing. That there's something I can't share.
I gave you all the rights. You can share your screen. Yeah.
Okay, then I don't understand why I'm not able to share, but it is in the chat now, the whole presentation.
Right. Do you
And
want me
also,
to share it from my screen? And you will tell me when I have to change the slides?
yeah, unfortunately, this is quite often, but okay, yeah, I think that's the only way, right? Because I can't.
Right. So I will share my screen. Can you see the screen?
Yeah, if you can make that
Good.
full screen, if you can launch it as full screen, then it's all.
Right. Can you see it? I can see it on my screen.
Yeah,
Good.
got it. Okay, then we get going again.
Thank you
Apologies
so
for
much.
this. I don't know why this doesn't work, but okay. Anyway, I will talk, as I mentioned, I will talk mostly about AI, but I'll also talk a little bit about the relations to our own intelligence. So that's what the IQ refers to, although I will not really talk about IQ, but I will talk a bit about our brain. And I understand you all have a very varied background from a lot of different areas. So I'll try to make it sort of a high level overview of what is happening in AI and what might be happening next. Yeah, could you go to the next slide? Yeah, so what I usually start with is obviously, I think we've all seen that this has, well, entered our lives, especially in recent years. So maybe I think if you can also raise your hand, right, in the Zoom layout. Maybe you can raise your hand if you, for example, use ChatGPT on a daily basis. I think we can see in all the pictures and also in the participants. So could you just raise your hand if you use this on a daily basis right now? Yeah, you can see this is quite a number of people, although when I'm looking at it, it's roughly a third. Yeah, so that's reasonable, but some of you also have not incorporated this on a daily basis yet, but you've seen that this is actually quite strongly impacting our lives by now. Okay, I see more and more hands coming in. Nice. Could you take the next slide? But I do think it's important to mention for starters that AI has, of course, been around for much longer, right? So I think many of you, or maybe even your parents, they probably already had something like a navigation software in their car 20 years ago. And this was, of course, also already AI. So this technology has been around for a long time, actually already since the mid 20th century. But if you click one more slide, something is changing. And many of us have actually experienced this in our daily lives, right? Because we've all started to use these language models, and well, they've been becoming part of our sort of our work routine. But there's way more happening also in the background. And I think this is not always emphasized, but for example, I don't know if anyone recognizes the image that I show here, what it refers to. Maybe somebody wants to say what it is. What does the image show here? Has anyone heard of this technology?
GPS?
GPS? No, I mean the AlphaFold in the bottom left.
Oh, sorry.
I think AlphaFold had to do with folding proteins in, I think, biology, but I'm not completely sure about it anymore.
Yeah, no, you're completely correct. Yeah, so this is actually the Nobel Prize in Chemistry from last year, about indeed how proteins fold into their 3D structure. But the interesting part, I guess, for us in this talk is that the Nobel Prize in Chemistry was won by a group of AI researchers. And that's what we call AI for science. That is the use of AI to enable breakthroughs in other scientific fields. And especially in the exact science, this is really taking off now, especially in chemistry and biology. So there is also way more happening that's usually not in our full view, right? Because, well, if you can win a Nobel Prize in another field, that probably shows what this technology can be capable of. Can you click one more slide? Can you, yeah. And that, well, I think that raises a lot of interest with people, right? Rightfully so, right? That's probably also why you are in this, well, in these meetings, right? You're also interested in AI, but there's also a lot of questions. And well, they can be many, but if you click one more slide, yeah, this means that for many people, AI is not only AI, but also a little bit a question mark if you flip the I. And these questions can be varied. They can be all kinds of ways. If you click 4 times, then I'll pop in. But questions can be, how does AI work on the inside? What should I be careful of when I use this technology now that we're all using it? Does this say anything about my own brain and thinking, right? Is there a relation between these two? And for many people also, where may this go in the future? I don't, of course, know what exact questions you have on mind, but I think quite often when I talk with people about AI, these are the things that sort of press them most. And I'll try to roughly cover these topics in this talk, go by all of them in a helicopter view. And if you click to the next slide, that starts with the start. If you click one more. So can anyone tell me when research in artificial intelligence actually started? How long has this stuff been around? I don't know if anyone has an idea. Yeah, you can just talk.
Olivier?
I think it's like 1954, like the first fundament of it.
Yeah, nice. Anyone else? Do you agree or do you think something else? Don't see other responses. No, you're super close actually. Indeed. So people often refer to the. I see Aurélie also.
Yeah, I think it was in 1950 with Alan Turing.
Yeah, nice. Also very good. Yeah. I'll walk by a few of the things that you've just said, but you're right, indeed. This is good, right? So many people are not aware of this, that this was already mid 20th century. And if you click one more slide, what we were, of course, waiting for was the digital computer. And well, this is actually how one of these first digital computers looked like. Way different than what we have these days, because we would program them actually by connecting these cables between certain points. That was how we would program a computer. And if you click one more, this is actually the ENIAC machine from 1945. So these computers were developed in the Second World War to decode, well, opponent cryptography, right? So messages of the opponent. So all parties were actually developing computers, but then after the war, they also came live for commercial purposes. And then, well, people started to use them also for artificial intelligence. If you click one more slide, then the question could be, why were we actually waiting for this computer, right? Because the question is, of course, for a computer, we know that we become intelligent from our own brain, right? That's that thing that's hiding in all our heads. And then at some point, if you click one more slide, we develop this computer. And then the question could, of course, be, why do we actually look at computers to replicate intelligence, right? Why did we not try a chair or a table or something else? Why were we waiting for this computer to actually start replicating intelligence? Does anyone want to give a try? Why was this computer so crucial to be developed? Yeah, Ria, go ahead.
Right. So as you mentioned, it was during the World War. We're looking at we were of course capable, but you don't find the same capabilities that easily. It is rare to find someone with those capabilities. So I believe it was to replicate that particular skill set and put it on a broader, much faster use, so as to like an inexhaustible computer can do it rather than a person. It's to expand your resources essentially, same as the industrial evolution, right? We automate things. That's what humans do, and it's a collaborative process. So that's my answer.
Yeah, I see that point. But why is particularly computer and not some other type of thing, right? What makes the computer so special? Maybe Vera?
Is it maybe because maybe automation? Sorry, automation because like repetition basically because like we do a lot of things that repeat a lot and like maybe we can delegate it to computers, something like that.
Yeah, okay, nice. I like the reasoning. Maybe you can click one more slide because I can reformulate this question actually into why, because we all know that a computer is essentially just a very big calculator, right? That's what calculators do, or that's what computers do. We use them for computations, and that eventually also puts this stuff on your screen. So why do we actually look at calculators to replicate intelligence? That is maybe the bigger question underneath. Yeah, and well, I'll move on now. I did like the answers, but if you click to the next slide, this is what we call computationalism. And maybe some of you have seen this, but the idea of computationalism is that intelligence is a computational process in its heart by itself. And that idea dates far back into the 7th century. There were already philosophers like Hobbes and Leibniz who said that thinking is nothing but reckoning. If you click one more slide. So they argued that intelligence by itself is a computational process. And well, you probably think, what do I mean with this? What does this even mean, right? Because it sounds so abstract. But if you click to the next slide, right, you're probably thinking, where are all these numbers in my brain then, right? Are you saying that there's a 6 over here and a 9 over here and a 3 over there? Is that the point, right? Am I now saying that your brain is actually composed of numbers? But that is not the point. That is not the point of computationalism. And that's also not the point of all of, I would say, exact science. So what we do in the exact sciences is, and actually that comes after the scientific revolution, is that we try to describe what happens in this world with a number, right? So I have, for example, pen in my hand, and if I drop this pen to the ground, then I can describe how quickly it falls with a certain number, right? I can describe its speeds with a number. And I also do this for my body. So for example, we describe heart rate with a number or blood pressure with a number. So we do this all the time where we describe a process in our world with numbers. And the idea of computationalism now is that this is also true for your brain, that the process that takes place in your brain, and it's a process of information processing, that can also be described by numbers. So if you click twice more, numbers, right? This is sort of the exact science view on this world, is that numbers are a way to describe what happens in this world, and that this can also be done for your brain, right? That you can describe it as a chain of connected computations, and I'll show this in a second. But this is sort of the first idea about intelligence that I think you should have heard of once or have seen once. This idea of intelligence as a computational process, something that can be described with numbers. So if you click on to the next slide, then we'll go to part 2, which is classical artificial intelligence, which is also a part I think you should have seen. If you click on to the next image, then I wanted to ask who is this, but now it's already visible. So this is Alan
I'm
Turing.
sorry,
No worries.
going too fast.
No, all good, because usually I would click through, but otherwise I have to say way too often. So this is fine. You can click on.
So
this is Alan
surprise,
Turing.
Alan Turing.
Yeah. So he's one of these first AI researchers. He was already mentioned just now.
Yeah.
And I think what is a really good exercise once to do is, if you click on 3 more slides, three times, is that you imagine for a second that you are Alan Turing. You're in the early 50s, and there's this new computer, and I give this computer to you. And I also give you a programmer, so you don't need to write your code yourself. And you're all intelligent, right? We are all intelligent every day. So this should not be too hard, right? We do this every day, being intelligent. So you only need to give the instructions to the computer to make it intelligent. You only need to tell the programmer what the computer needs to do. And well, since we all do this every day, this shouldn't be too hard. So I want to ask you to think about this for just 15 seconds, and then maybe somebody can share if they have an idea how they would approach this. In the meantime, you can already click to the next slide. Just the first one. Yeah. So this is the question to you, actually. All right. Is there anyone who wants to sort of give a high-level idea of how they would maybe approach this?
Apologies, my camera is off because I had a few Wi-Fi issues, but I think I would start by, since I know that humans are intelligent, I would try to replicate as much as possible human reasoning behind this. And for example, start with the command of instructions that I want, and then also what I want at the end to have.
Yeah, nice. Okay, so you're thinking about reasoning. That's really good. Yeah, and you have sort of a path to it. I see Ria.
So I see what the previous answer said. I think I would start with use cases, right? Of what we're trying to achieve. So some real life examples for it to train on. That's what it would be. It would have to be a sample of whenever you want something done, even when you're training a dog, you have to show what you want done and then break it down into steps. So it would be somewhat like that.
Okay, nice. So you want to start from tasks and break them down in certain steps. Yeah. Any other? I mean, I already like these ideas. I think if you click twice more, or three times more, yeah. So what the answer of the early AI researchers was, and that's also what I hear a little bit in your answers, is you want to sort of think about how do we actually do things, right? So for example, how do we reason? And then we want to try to disentangle this and then program that ID into a computer. And this is clearly also the intuitive ID, also the first AI researchers came up with. And I'll quickly show you an example of how this works. So if you click to the next slide. So I'll take the example of reasoning, which was actually mentioned also as the first answer because it was such a key thing of the first AI approach, and it's also such a key thing of our intelligence, right? Our ability to reason. So if you click twice more, then this could actually already be formalized through logic. We knew that for a long time. So that already dates back to Aristotle in the 4th century before Christ. And I'll show you a quick example of how this reasoning based on logic works. Some of you might have seen this before, but if you click on, then reasoning always starts with an observation or a fact. So for example, I can look outside and see that it rains. It actually rains here a little bit in my place now. So an observation or fact that it rains can be, for example, true. Then the second step, if you click one on, is that you have to specify decision rules. So for example, you can have the rule, if it rains, and then I need a jacket. So these rules usually take a form of if-then type of relation. So if it rains, then I need a jacket. Now, if I have the first observation, that fact, and I have that decision rule, then I can draw a conclusion, which is the third step, if you click once more. And that third step is that you then need to put on a jacket, right? So you can derive a new fact or a new conclusion based on these decision rules. And then if you click once more, you can use that new fact, you can add it to your observations, and then maybe you have another rule and you can make a next step, right? So for example, if you have a jacket on, you need to do something else. So in this way, you can build reasoning based on logic. And if you click once more, then the magic of this process is actually hiding in these decision rules, right? Because actually what they thought is let's compress intelligence into intelligent if-then like relations. So for AI, we needed to program the right decision rules. And that's also what researchers started to do. So if you click on once more, they started to build huge knowledge bases, which were essentially databases full of rules, and these were gigantic. So they built databases with up to 25 million handwritten decision rules, which is an enormous amount, right? So this took a lot of work. And the question is now, if you take one more, is the problem solved? Oh, wait, one back. So the question is the problem solved or not? Does anyone want to answer?
No, it was not solved.
Pardon?
No, I don't think so. Like with such a huge amount of data, the problem cannot be solved because handling the data will be again one task.
Yeah. Yeah. So I like your intuition. So you're saying, well, you're sort of saying a database of 25 million rules you cannot oversee, you cannot handle as a human. So you think
Yes.
this will break. Yeah. Are there other ideas?
I think you need a way to connect those knowledge, right? If you don't know how that is done, so you can have a lot of data, but if you don't provide a means to connect and arrive at conclusion, these data may be useless. That's what I think.
Yeah. Good idea. Just to be clear, it's not per se data. It's essentially human coded rules, right? So this was not data we drew from the world. We were essentially coding how am I thinking myself, and then they coded that into a rule. But I do think both of your ideas are very good because well, that's, if you click one more slide on, we can actually look inside this building, what's going on. And if you click once more, if we look inside, what happened is with these AI researchers is that if you stand in this gigantic database, this knowledge base with all kinds of concepts, at some point you can't oversee anymore how to connect them, right? Because maybe if it rains, but if this and that, then maybe in this case I should do that. But just in another case, I should maybe also think about this. And at some point, these databases became unmanageable because we clearly could not oversee how everything was connected and how all concepts, which concepts should be taken into account and how we actually make decisions then. And therefore, if you click one more slide, it turned out nobody could see how everything was connected. And therefore, if you click once more, oh, this building collapsed, and it collapsed pretty hard. So there have been major AI crises back in the day, and actually two big AI winters. And this fall is somewhere late 80s, mid 90s. But it really crashed. So all trust in AI was essentially gone because we could not scale this. And I think you should have seen this once, because if you click to the next slide, I think the biggest lesson of classical AI research, of the first phase of AI research, and that is that we cannot fully oversee our own intelligence, right? We can try to describe it up to a certain level, but we cannot describe it in that level of detail that we can actually implement it ourselves. And that's a very tough conclusion. It's sort of a painful conclusion for us humans, but it is true, right? In some way, we are looking at our own brain, and that's a gigantically complex organ, in which I'll get into a second. And we can sort of describe what's happening there on a higher level, but we cannot really describe it in detail good enough to actually implement it ourselves. And therefore, we sort of hit our head against the wall. And that's also the reason why AI these days works as it works. And if you click one more slide, this first intuitive approach to AI, where we try to rebuild it based on our own insight of how intelligence works, failed. It failed the hard way. Not all AI researchers have still accepted this, but it is true if you see which types of methods are dominating these days. And that brings me to the next part of the presentation, sort of the main core, which is machine learning, which is another kind of thinking, which is, well, way more dominant these days, which departs from the question of what makes our own intelligence actually possible. And if you click one more slide, then this is clearly our brain. Yeah, so starting with our brain, I want to present a view on our brain in a sort of an abstract way, the way you can think about this. So our brain is an organ that is, well, we never see it during our lives. It's hidden in our head, but roughly what it does is that on one side, if you click one more slide, our brain is actually connected to our senses, or our senses actually consists of nerve cells. So at this moment in your eye, in the back of your eye, there's actually nerve cells that are catching light from the environment. And in your ear, there's also nerve cells that are catching sound from the environment. So that's one side of your brain. And then on the other side, if you click once more, your brain actually influences some type of action or output, right? So you can be running, but also I am moving my mouth right now, or actually I'm producing sound, and I'm producing sound by moving my mouth and moving my diaphragm. And that's all influenced by nerve cells. So my nerve cells are continuously, on one side, it's taking input from the environment, sensory information, and on the other side, there are certain nerves that end, for example, my muscles or my hormone distribution. So this is what your brain essentially does. And in between, it is actually doing something. It's processing information. So if you click one more slide, the key magic is that for intelligence, we must somehow convert perception into a smart, appropriate action. This is what your brain does at an abstract level, right? It combines what you perceive to how you should respond. Now, maybe we can take this view as a basis of intelligence. And therefore, on the next slide, if you click one more, I want to take you quickly a slightly deeper look into that brain. So I'll do a one slide on Neuroscience 101, because your brain is actually composed of nerve cells, which we call neurons. I already saw that in the chat, I think also somebody mentioning neurons. So neuron is a pretty special cell, and here it's schematically depicted. But if you click one more slide, what a neuron does is, well, for example, in the back of your eye, based on what comes in from the environment, so based on the light that falls in onto a neuron, it can start firing. And with firing, we just mean that it emits a small electric current. And I've drawn this with this arrow. So this neuron starts to send an electric signal based on what it perceives from the environment. Then if you click one more slide, that neuron is actually connected to a next neuron. So this is also what makes them special. Neurons connect to each other. And in that connection, if you click one more slide, they are messaging each other. And what they are messaging is that they can stimulate or inhibit them with a certain strength. So they can, if you click one more slide, for example, say to the next neuron, you got to work 3 times faster. So I'm firing, I'm giving electric current, but you should also start firing harder. You should actually give 3 electric signals. And that neuron, if you click one more slide, is connected again to a next neuron. And if you click once more, that is again at some point connected to, well, for example, your muscles. And that's why you can run or walk, or why I can move my hand at this moment. Right? It's essentially a chain of nerve cells that are influencing each other and eventually determine how I move. Now, if you click one more slide, of course, there's not only neurons in my eye, but there's way more neurons. There's actually already millions of neurons in my eye, but there's also a lot of them in my ear and on my skin, in my senses. And if you click one more slide, then all these neurons connect to each other in a gigantic network where they're all sending signals to each other. You got to work faster. You got to work slower. And this sense, this is the way I run, but that's also why, well, how I can talk at this moment, right? It's nerve cells that are actually steering the way my mouth is moving at this moment. Now, so if you click one more slide, the big magic of your brain is that it is a gigantic network of neurons that somehow connect perception to action. And the question now is, if you click one more slide, what determines how information flows through this network, right? How is perception connected to action? And that magic I've already discussed in some way, because if you click once more, it hides in the strength of all these connections, right? If I change those connections, the strengths, there will also be a different pattern that comes out of this network. So for example, if you click once more, there can be, over there can be a point where it says 5 times faster. And if you click once more, this is like a coach that actually says, no, one back. Yeah, this is a coach that, for example, says you got to fire 5 times faster at a certain point. Yeah, so that's how you can imagine sort of all these connections between neurons. And at another point, if you click once more, there might be a coach that actually says 3 times slower. So you can think of that, if you click once more, as a coach that actually says to the next neuron, hey, play it down a little bit, not so fast. Now, all these coaches on all these intersections between these neurons in your mind or in your brain, they actually determine how what goes in is connected to what comes out. Right? So, and you see the numbers appearing here, right? Because what is happening is neurons are telling next neurons whether they should go faster or slower. You can express that with a number. And all these numbers together essentially determine how the input is connected to the output. Yeah. So if you click one slide more, this determines what you eventually do, right? We need to figure out how all these connections are organized in our life or in our brain. Now, this idea also inspired artificial intelligence researchers, and therefore, if you click one more slide, they try to push this into artificial neural networks. So can we replicate these principles in a computer? Now, let's give this a try, whether we can do this. So we're now going to build a network in a computer that is going to connect input to output, right? We're going to connect some form of perception to some type of response. And I'll give the example of a language model of ChatGPT, for example. So let's start with an input. So if you click once more, for example, you could take, well, I'm in the Netherlands right now, so I took this example. Imagine you ask the question, what is the capital of the Netherlands, to ChatGPT. Now, what you first always need to do is computers in the background operate on numbers. So you convert that sentence into numbers. So if you click once more, the easiest thing is, for example, to just assign a number to every letter. But imagine this sentence somehow turns into 5, 3, 2, and then some other numbers, right? So we convert this text into numbers. And then we have a network. And well, we know now that that network needs certain connections, right? We need the strength of all the connections, but we have no clue. So let's just put them at random numbers. So if you click once more, then you see that I just picked some random connection strengths here. So this first neuron there tells the next neuron go 3 times faster. And then on the second step there, a neuron tells the next one, or you got to go 5 times slower. And all these connections, all these lines, black lines, have some connection strength that we just randomly assign. And well, if we know the input of this network and we know all these connections, we can compute what comes out. So if you click once more, maybe the output of the network is 1, 3, 6, and well, some other numbers. And now the question to you is, if you click one slide more, not more, what is the answer of this network? Can somebody tell me what they think this network will answer to this question? If we convert this back to letters, right? So now we take the output, we make it back into letters, and that's what we show you as an answer. What do you think the answer will be?
Yes, Jamia.
Yeah, go ahead, Samir.
Amsterdam.
Amsterdam, okay.
Yeah,
Is there
because it's
another idea?
answering the question at the end of the process.
Yeah, okay. So you're saying Amsterdam. Are there other IDs, other answers that you think it might give?
It could, but like the question was straightforward, so I don't know.
Yeah. No, it's all good. I just wonder if somebody else has another idea, or whether you agree it will be Amsterdam, or whether people think differently. Okay, seems like you all agree it will be Amsterdam. Yeah, I see the intuition, right? But maybe let's take a look, because I tried this myself. And so if you click one more slide, you'll see what the answer actually is. So the answer is book 13 exclamation mark trampoline. Or actually, it's even worse actually in practice. But if you click one more slide, you see that something goes wrong here, right? This answer is wrong, but what goes wrong here? Why does this not work? What have we forgotten here? Is that something? So we took the sentence, we changed it into numbers, then we took some random connections, random strengths in this network, and then some numbers came out. Why is this answer so stupid?
Because of the random connections of the network, it's giving
Yeah.
random answer can be the possibility or not.
Yeah, really good. Yeah, nice. This is it, right? So we took a random network with random connections. This will give a random answer to a question, right? And those are usually not smart. So intelligence actually demands a highly specific type of information processing. And most of them, if we randomly pick one, will not be intelligent at all, right? So if you click one more slide, a network with all these random connections weights also gives random answers. Right? So this is what then AI researchers ran into. We can make a network in a computer, we can simulate a neural network in a computer, but a random neural network will usually not be smart at all. It will be very stupid. Yeah. So what did they do? Well, if you move to the next slide, we're now moving into the topic of learning, because what we usually don't realize is that we think this is very stupid from the network, but actually it's also true for us when we're born, right? So if you ask a baby the question I just asked, what is the capital of the Netherlands? Then a young child will also not answer that question, right? So if you click one more, if you ask that question to a baby, it will probably bite in a ball or something, but it will definitely not say Amsterdam yet. But then over time, if you click one more, after time that child goes to school, and there's a teacher, and they start to talk about, well, the capital of the country where you grow up and the capital of other countries. And then after a while, this child might start saying, hey, the capital of the Netherlands is actually Amsterdam. So we humans, right, we're also not born with a very advanced intelligence, but if you click one more, for a large part, we are actually learning during our life from experience. And that's something we can't shut off, right? We're all doing it at every moment. So continuously we're gathering experience, and our network in our brain is actually changing and adapting. Now, if you click one more, the question is, of course, can we also apply similar principles in computers? Yeah, but then it's not that different actually from what we do during our lives, but we call it slightly different, because if you click one more, the idea becomes, can we feed a computer with data, with experience, with things, right? Like a teacher that is telling you the capital of the Netherlands is Amsterdam. And this is what we call machine learning. So if you click one more, machine learning is when we let a computer learn from data. And I made an underline for experience and data, because usually we think a computer only learns from data and cannot be smart. But it's just because we call experience in computers, we give it a different name, right? In computers, we suddenly call it data. And in our lifetime, we call it experience. but they're technically the same thing, right? It's experience from the real world from which you learn. And this process is therefore not that alien or that different from what we go through during our own lives, right? So what we need to go after is, can we make this computer somehow learn from data? And if you go to the next slide, I just want to show you to this once because I think it's not that difficult actually. It's very easy to understand for everyone conceptually what happens. So it starts with a data set, right? You need some experience to learn from. And in this case, we're doing text. So we just pulled all textual data from the internet. And for example, in that data, there might be a sentence like, what is the capital of the Netherlands? And then somebody on that forum answered, the capital of the Netherlands is Amsterdam. Or there was a question of, what do you call learning in computers? And then there was behind it, that's called machine learning, right? So in your data, you have examples of, well, questions with answers. If you click on twice, one more. Then the second thing we need is this first neural network, right? So we put a neural network in a computer. That's what AI researchers do all the time. And we initialize this neural network with some random connection weights, as we just did. So for example, we put it to 3, -5, 1, and -4. Well, we know this network is not smart at all yet, right? But that's what we do want to achieve in the long run. And now we will start training. Now, the first thing you do is, if you click one more, is that you just take a first sentence and you put it into the network. So we turn it into numbers. If you click one more, we compute the outcome. And this could, for example, be that 13 trampoline exclamation mark. And what we then do is that we compare it to the true outcome. If you click once more. So we compare what the network says to what is actually the good smart response, which is the answer, the capital for the Netherlands is Amsterdam. Now, clearly in the beginning of this process, this will not go well. So if you click one more, there will be an error, right? We see that the network actually makes a mistake. It says something, but that's not what it should say. So there's an error. And then the magic of learning is that we look back, if you click one more slide, is that we look back into the network and we're going to adjust all these connection weights, all these numbers in the network, so that the output does actually become correct, or at least becomes better. Yeah, so if you click one more, you'll see the numbers change. And now you see they changed, no, one back. They changed to 2, -6, to a -3. That's different as the one before, right? So we made an adjustment to our network to make sure the prediction improves. Now, what we then do next is we go to the next example. So for example, if you click one more, we push in the next question, which is, what do you call learning in computers? We do the same thing. If you click one more, we make a prediction. You can click 2 or 3 more, because then we compare it to the output again. We compute the error, and then again we look back and we make the adjustment. So now if you adjust again, if you click one more, it goes to 1, -7, 3, and -4. Now this process we repeat for a very, very long time. This is why there's so many data centers these days. So if you click one more, sometimes somewhere along the highway, you see these huge data centers arising all over the world. They also demand a lot of compute power and energy because you need to do this for a very, very long time. For example, you need to iterate over the entire internet. Yeah. But if you do this for a few months, and then at some point you stop, if you click one more, then you, for example, end up on this network, which has the connection weights of 3, 6, -1, and 2. So you, for a long time, you've been changing this network every time to give the correct answer to a certain input. Now, if you're done after all these months, and if you then put in the question, what is the capital of the Netherlands? And you compute the answer. So if you click one more, then the network will suddenly correctly answer, the capital of the Netherlands is Amsterdam. And this is essentially all that this modern AI is actually doing, right? You start with a random network, you take a lot of data, you push something in, you check what it says, you compare it to the correct answer, and then you change the network so that the answers become better. Yeah. So in some way, this is pretty simple, right? Because I hope this is in some way, a bit sobering about what AI is. Because essentially, it's nothing more than this collection of weights in this network. It's this huge collection of numbers. So essentially, a big AI model, a state-of-the-art AI model, such as ChatGPT or some other LLM, is nothing more than a huge collection of numbers, right? But they're very expensive numbers. They're very expensive numbers to obtain and to compute. So this is on one way, this is all AI is in some way. At the same time, it might also make you think a bit different of your own brain. because essentially this is also what is happening during our own lifetime in our brain, right? You start with a certain network that is already a bit initialized through evolution, and then over time we see, if we look in neuroscience in your brain, the network in your brain is continuously adapting, right? So these strengths of connections between neurons in your brain are also continuously adjusting based on data, right? So at the same time, AI is nothing but a collection of numbers. On the other hand, you might also reflect a little bit on what is happening in our own brain during our lifetimes, which is continuously adjusting. Yeah, I see a question.
Yes, sir. Here I wanted to know, since it was a very straightforward answer, so every time the continuous re-evaluation was possible. In case of questions which are not that straightforward, like we ourselves as a human, we don't know the answer. In that case, how the neural network will adjust and find out what is like correct to do the comparison.
Yeah, yes, your point. So as AI researchers, we don't, in all honesty, we don't really care about what is the correct answer, because we will just take the answer that is in the data. So if people answer different to that question, and if sometimes there's answer A in the data and sometimes there's answer B in the data, then we will train on all that data, and the network will therefore also say sometimes answer A and sometimes answer B. So technically, we sort of take the perspective that whatever is in the data is the correct answer, and we learn from. And we don't do data cleaning because there's so much data available to judge what we consider the correct answer or not. So I hope that sort of answers your question.
Yeah.
If there's multiple answers, then the network will also start giving multiple answers.
Okay.
Does that make sense? Yeah.
Yes.
All right. But we can, of course, have a meta discussion about this later on, about is there then truth in here? Let's maybe move to the next slide then. I'm almost done for the training process. I think the key realization, once you sort of have understood it, is that what I've just shown you is the hammer we're hitting with in all of AI research. So essentially, we're doing nothing different than what I've just shown you for language. We do it for everything. So we're essentially a one-trick pony in AI. So if you click once more, then this example is about text, but it works for any type of data. So if you click once more, what we can, for example, do is we can take as input, we can take the camera of a robot, and then as output, we can predict how the robot needs to move. Or as input, we can take the characteristics of a patient, and then for the output, we can predict what disease the patient has or what type of medication it needs. We can also take the air pressure patterns around the globe, and then we can try to predict what weather it will be tomorrow, what the temperature will be. Or we can take in a chain of amino acids, and we can try to predict the 3D structure of a protein, which was actually the Nobel Prize I told you about in the beginning. So every time you read about a new application of AI, it is the same trick underneath. It is the trick I just showed you, right? So there is nothing about AI researchers that we understand anything about proteins or that we understand anything about medicine. The only thing we sort of needed to understand is how do we learn from data. So if you click once more, right? All of modern AI runs on this same underlying principle that I've just shown you of taking an input, going to the network, checking whether the output is correct, and then adjusting the network to give better predictions. Yeah. So one of the biggest lessons of the second part of AI research is that essentially, if you click one more, is that learning is eventually the key to advanced intelligence. This is the process we need to figure out, right? This is the one thing that it's all about. Can we figure out how we can learn from experience? And then we apply this in any task we have at hand in AI, right? So don't be mistaken that there's a lot of different stuff happening underneath. Essentially, we've been after this one scheme of learning, and we're just studying a lot of variations of it. And then we apply it to different types of data. If you click one more. Yeah, maybe, yeah, click one more. And one more. Yeah, so what I haven't discussed yet so far, I've basically been talking about pretty small networks, or it looked like it were small networks, but actually our brain is huge, like really, really huge. So if you click one more, but not two, just one. Oh no, sorry, this is not here yet. So in our brain, there's about a quadrillion connections, and this is a huge number. So that's 10 to the power 15. You almost can't imagine how much this is. This is a million times a billion. And that all fits in all our heads, right? I mean, the volume in your head is roughly 1.5 liters. So that's a bit like a bottle of Coke in size. But in there, there's a quadrillion number of connections hiding. And that's not for fun, right? We need these large networks with these huge amounts of connections to get to the complexity that we're able to achieve. And evolution therefore tuned us for a very long time, and we ended up with these big brains. And this is also true in computers. So if you click once more, this is also what we do in computers, and therefore we use what we call deep learning. Don't click on yet, because I wanted to ask you the question for a big, current AI model such as GPT-5, whether you think this has more or less connections than our brain. Maybe I can see hands for those who think this has more connections.
Ria?
Yeah, and can I see hands for those people who think that it has less connections? Yeah, that's quite a few more. Okay, well, if you click one more, then this is not publicly disclosed, right? I mean, OpenAI does not disclose that, nor do the other big companies. But the rough estimates are that it's about 1 trillion connections. And that is still a factor 1,000 below our brain. So these AI models are huge, absolutely huge, but they are still a factor 1,000 smaller in size than the brain is, than your brain is. And I think this is also a bit of an admiration for whatever crazy organ was actually designed in us by evolution in our skull, which we never see. Now, don't be mistaken that it's only about size, right? Because you also need to use them in the right way with the right learning algorithm. But size does matter in AI. So if you click one more, these networks needed to be made huge, right? And that's also a lesson, is that advanced intelligence demands enormous complexity in the sizes of these networks. So the recipe by which we train them is simple, but the network needs to be huge to actually get to the complexity we want. And that comes with a downside, if you go to the next slide. And that's the downside of interpretation, about which there's a lot of, confusion, I would say, because no human can ever oversee the role of all those trillions of connections, right? So if you click one more, when we look at advanced AI models, we see that they work. Something goes in, something comes out, but we cannot fully explain what every connection in this network actually does or how it contributes to the outcome, because we've just been adjusting these numbers to get the correct outcomes, but we have no clue what every connection of these trillion connections exactly does and why it needs to be a particular number, right? And that's why if you click one more, we call these AI models, are sometimes called black box models, because we've trained them by design that something goes in and we check that something correct comes out, but we let sort of the optimization, the computer, figure out what all the numbers should be. And this is true, but it's also a lot of confusion about this in the real world for two reasons. So if you click one more, the first thing is that this also holds for our own brain, right? We also can't explain what we do at the level of our neurons. Nobody has ever explained in us how we do what we do, right? We also have these quadrillion numbers of connections. So we demand something from the AI here that we don't really demand from ourselves, right? Because nobody will ever oversee such a big network. And the second thing you should realize about this, if you click one more, is that it doesn't mean that AI started doing something by itself, which I often see in media, that we say, yeah, these are black box models, we don't understand what it does. We explicitly designed it this way, right? We set it up, we set up the huge network, and we set up the training scheme to work this way only because we realized it is necessary to achieve advanced intelligence, right? So this is not something we do for fun or that the AI was turned into a runaway intelligence. We specifically designed it this way because it's necessary. Yeah. And then, if you click once more, I think I'll round off on this part. So to summarize, you can look at intelligence as a stream of information from perception to action. If you click one more, then neural networks make this possible, this flexible stream of information, right? And then how this information streams from perception to action is based on these connection strengths. If you click one more, then we tune these networks. We tune this modern AI based on learning from experience or data. And therefore we collect these huge data sets on the internet, but it's not much different from all the data we learn from, all the experience during our lifetimes. And finally, I think a key realization is that all of modern AI is based on the same underlying principle, just every time applied to different data. So this is essentially, in a quick outline, what is happening these days inside of machine learning. If you click one more, I had a part about the future, but I think given the time and also the delay, I think we'll skip this part. And I think it could be nice to move to question and discussion. So you could skip the next slides and sort of move to the end. I think that would be, otherwise there's no time left. I had some part about data, some part about compute power, but I think if you have any questions, we can still talk about this, and some part about AI safety. But well, we'll leave that for now. Yeah. And conclusions, then we can also skip, I guess, because this is sort of, well, the high level idea of what I've spoken about in this whole talk, that classic AI did not work, that machine learning works much better, and that you cannot fully verify or interpret the internal workings of these networks. Yeah. So that's it. I think you can then move to the last slide on the questions.
Could I ask if you might just make a very quick movement over the future? Because I think it is really interesting to hear your perspective on how you would foresee the future of it. I know there's very limited time, but I think this might be really interesting for the thing that we have to discuss the 26th of March.
Yes, I mean, for the 26th of March, what students have to do is to they will have a scenario, and they will have to discuss about the future of education in an AI-driven world. So understanding the process of learning was very important. But I suppose having your insights about what you think the future of education would be, or the future of learning would be very interesting. But I suppose it might be also there might be some questions about it as well. So I don't know whether you wanted to answer this question directly, Professor Merland, or if we ask the question and open the Q&A session.
Yeah, for me, both are fine. I'm also fine to just take a few questions and see if it comes up along the way.
Good.
That's also totally fine. Then we can still just...
Yes, we have 20 minutes, 22 minutes for the questions. So yes, Ashuman?
Hello, everyone. Thank you very much for the training, first of all. And I do have a question which directly relates to the future. So as you mentioned that we cannot fully oversee over our own intelligence. So related to that, and like we are trying to replicate our own intelligence in quantum computers and artificial intelligence, trying to make it faster, better, precise. So now that there's synthetic data and synthetic intelligence available, which replicates our data and tries to make new variations of it and learn through it, my question to you is, in present world scenario, can this reinforced learning, can this AI contribute to the research world autonomously without any human intervention and make a new discovery out of it?
Yeah, thanks for the question. Yeah, in theory, it definitely could. And you also see a little bit of the first parts appearing of AI autonomously doing research, especially in computer science, also running its own experiments and analyzing and interpreting it. So I definitely think there's no conceptual barrier for AI making true new discoveries. To be very fair, we're not there at this moment yet, right? So we don't really see AI published papers yet. This Nobel Prize, it was clearly won by the human AI researchers that actually came up with the question and set up the whole training pipeline and design scheme. But in theory, it should definitely be possible, I think, for a more advanced AI to actually make autonomous discoveries. But in which time frame that will appear is really hard to predict. And that is maybe one of the things I would have said about the future as well, is that you see a lot of pretty strong predictions about the future by a lot of AI experts. But even the top AI experts in the field quite strongly disagree about the speed with which this will progress. Even the sort of the computer science Nobel Prize winners are completely disagreeing. And this is also what you see in the history of AI, that we've been wrong many times about how fast certain things would develop. So I think it's conceptually very well possible, but with which speed this will come, I think there's just a huge uncertainty around it for different reasons, because there's so much uncertainty around the future of data, there's so much uncertainty about the future of compute, and we have huge trouble estimating the difference between this relatively simple learning scheme I showed today, so the learning algorithms in computers, and the complexity of the learning algorithms in our brain, right? I think we have really we have trouble estimating how complex we are due to our long evolutionary history. This is something we struggle with, and we can't really judge how big the gap is still left, in all honesty.
Right.
Does that
Thank you.
answer
Thank
the
you very
question?
much. Yes, yes, it does. Thank you very much.
Aparna?
Hi, so my question for today was, so when we started the presentation, you were talking about IQ and AI going hand in hand. So when we are focused more on AI and education, so we know ChatGPT came, it bloomed to go in the, it was just for a few years back. And we see how AI is contributing to education right now and how much we depend on it. But do you think that allowing young minds and allowing them to completely depend on AI for tutoring or lesson course planning is going to, affect their IQ, is going to affect them more, more the critical thinking of them is going to decrease or increase. What is your take on it? This is my question.
Yeah, I agree. Well, yeah, so I did not talk about education at all, but I'm of course also work in education. And I think this is indeed, yeah, a small or maybe not even a small, a big nightmare that's happening at this moment in education. Yeah, so I think we've seen something similar maybe already with the Industrial Revolution, which was mentioned before. So the moment we made machines for our physical labor, then after that we suddenly need to start to build gyms to keep ourselves in physical shape. And I think something similar might be happening at this moment with natural intelligence. We're now automating cognitive processes, and I don't think we're fully aware yet of the complete nightmare that's taking place in education. So if I talk to students in an anonymous setting, or if they're not, for example, my students, and they admit how much they use AI for essentially all their homework, then I think we're majorly running behind a complete crisis where we are essentially educating a whole generation with a strong dependence on assisted tools for their cognitive skills. And I think as with many things in our society, usually it enters and then it takes us 10 years or 15 years to realize how bad it is. And we've seen it with smoking, we've seen it with social media. It takes years before we start to take action. And I'm afraid the same thing is happening with AI in education now, because we probably need to rebuild our whole education system where we do way more on-the-spot examinations, or we're really, not because students have a bad intention, right? But just if you have a busy life, there's so many temptations, you resort to AI when you're close to a deadline. And that looks fun at first, or it's easy at first, but after a few times you've fallen so far behind that you can't even catch up anymore. And you've sort of become addicted to the AI. So yeah, I really think there's a major crisis hiding in all our institutions, all our educational institutions around the world.
Yes, yes. Thank you, Professor. It will be exactly the topic of the scenario we are giving them. They will play the role of national delegation stakeholders on the global side, and what they have to do is to see how we can adopt actionable recommendation in order to mitigate the risks and go and build the future of education together. So yeah, they are this younger generation. They need to discuss it properly, and we are very proud of them being in a way, the ambassadors of what they can see locally and think all together globally. Thank you.
Nice. No, that sounds very useful.
Thank you. Ria?
Yes. So I'll make it quick. In India, there's a court case in the Delhi High Court in which one of the amicus curiae, one of the friends of the court, is essentially making this comparison that AI is learning like a human learns, right? Like how a human learns. So the court case is about intellectual property. So I was thinking about the education system and a lot, of course, the education system will have to be changed to sort of mold into adapting AI is what seems to be coming across more and more that we talk about it. But what is your opinion? Because we have generative AI and we have, I think, a higher analytical AI, which is actually used in medicine cases and in science cases. But generative AI essentially looks at, oh, what should the answer sound like, right? What would the user want to hear? Right? What do you think is going to be, which AI would be used in education and what would be like the most ethical concern? So it's a two-tiered question, right? So can an AI be analytical enough to sort of uh, give us that give us that platform to essentially teach in its own way, or would it be more generative? That's my question.
Yeah, well, to be honest, I don't see a distinction between generative AI and analytical AI in the sense that they're all essentially trained with the same recipe underneath. So I think what you do see is that in these LLM models, you have sort of sometimes we introduce some reasoning loops, which are just querying the model a bit more to make a few more passes and then reflect on its own output. But essentially, it's all the same mechanism underneath. It's all essentially trained on, well, just on human data so far. And then we try to improve it a little bit beyond. But so I would not clearly make a distinction. I think it's all essentially reproducing and building, generalizing from existing knowledge. The question is whether that could be useful in education. I definitely think there's also a strong case for it being, right? So I just sort of pictured the big problem, and I think the problem is definitely the main thing that should be on the agenda. But at the same time, I think these models are also technically the ideal teacher, although they're not completely verifiable, right? So they can always make mistakes at unpredictable moments, but they are a bit like a universal teacher. I mean, if you try out with your favorite LLM, you know a little bit about the topic and you start to query it, there's no teacher in this world who can give this amount of variety of knowledge, who can oversee this type of knowledge. And also, it's like an interactive book, basically. You don't need to search a textbook and search for an answer. It almost interactively gives you access to knowledge. The risk is, of course, that it's not fully verifiable and it can make mistakes. But as a teacher support tool, this is also, of course, an amazing opportunity, right? We've essentially built the general interactive textbook that we can query on anything we want. So there should be vast opportunities in theory. It's just that I think that the risks of us misusing it are way bigger at this moment. But I definitely think this technology is highly capable of also being a really good teaching tool. Does that answer your question? Is that sort of where you wanted to go or not?
Yes, that's perfect. You gave me the biggest risk. Thank you.
Okay.
Thank you. Aurélien?
Yes, can you hear me?
Oh, I suppose we had Gori before. I'm sorry, Gori. Gori, you're and
No,
Aurélien, you will be next. Sorry about that. Gori?
Yes. So I have read one of your blogs. So you are against banning AI in education, but rather you advocate for reimagining how we educate ourselves. So I was recently listening to a TEDx talk of the founder of Khan Academy. He was talking about built-in guardrails in AI. Can't we go in that case? So he was looking at what kinds of guardrails can be built in a particular AI that will help students to actually follow their knowledge rather than looking at AI as a replacement, as you kind of argue in your blog as well. So would you shed light on what kind of guardrails do you envision the companies build into their AI to rather support education rather than, like viewed as a replacement?
Yeah, no, I see your point. Thanks for reading the blog post. So what I think is that you can definitely conceptually build AI with certain guardrails that would only, for example, give the type of advice that a teacher would give, right? So if a student asks me a question, I will not give the answer to them. I will try to help them in the right direction to let them find the answer themselves. So those kind of guardrails, I mean, you can easily train such a system on, well, being reluctant to giving exact answers and only wanting to give guidelines. The big problem, I think, is that we can probably never enforce that all the big companies with all their major AI will only build AI this way. So we can definitely, and I see this as well in my own institution in the university, they're all after building AI with sort of educational directions. And that's great, right? I'm all in favor of an AI that would only give advice and directions as a teacher would, right? Because it's essentially a support teacher that's always available. The problem is that the student goes home and they have all the AI available that we have in our general world. So it's amazing to build supportive AI, but it does not exclude the problem of somebody who wants to use AI as a replacement. I think it will be a utopia to think that we will ever make sure that students do not have access to an AI that will give all the answers. And I also think we cannot put the responsibility on students, especially the young ones, to give it to them, make it their responsibility to then not use that other form of AI. So I think there's major opportunities of developing education-proof AI, but I think there's almost zero opportunity to ensure that students will not also have access to the fully broad AI that will just replace them or replace their work. Does that make sense? Or is that sort of
Yes, yes. Thank you so much.
Right, Aurelia?
Yes. We talked a lot about the students and the use of AI by the students. So I wanted to go a bit on the other side and to ask you, from your point of view, to what extent should the teacher use AI for some sort of personalized learning and so on?
Yeah, it's a good question. Yeah, so I also see at university that there's a lot of interest in, yeah, what can AI do for teachers? And of course, there is in theory a lot of potential, or actually in practice, there's a lot of potential. But I'm also a bit worried about this because what I see here is that they give teachers, for example, they give them courses in designing assignments with AI and also courses in grading assignments with AI. And then, I mean, I do think there's some naiveness in there in the sense that if you start to design your assignment with AI and you start to grade it, well, you can almost also plug in, make the assignment with AI and let the whole thing be generated, answered, and graded at once by the AI, right? So I think, yeah, I think it gets a bit back to the question before. We could, and probably, I mean, it's definitely feasible. The problem is, of course, that until we've solved the students also using the AI to answer that same assignment, I think we should probably not even start thinking about how we might use it ourselves, right? Because there's a huge, yeah, we're sort of completely ignoring or sort of blindfolded if we only start focusing on how we might make our lives easier, right? I think the first question should be is how can we make our education system survive at all? And I think all the effort that we are now pushing, also at my institute, right? We're pushing all this effort into what fun stuff can we do with AI? And I do think, yeah, when I sit in such a meeting, I'm sort of baffled by how naive that sometimes can be. So, yeah, my answer would be there's a lot of opportunity, but I don't think we should even think about it until we have the feeling that we've solved our own educational system design.
Okay.
Yes.
Thank you. Gopika?
Ma'am, I think Manish has before me.
Sorry?
Manish has before me, so I'll let her ask the
okay.
question first.
Okay, that's okay for me. Manisha, if you want to go first. Thank you.
Yeah. Thank you so much, Gopika. So my question was very straight. In your slide, I saw one of the question like, what should be I careful of about using this AI technology? So could you just conclude that part? Like
Yeah,
what people should be careful of?
Yeah, so this would have been also part of the future slides. But what I would have said there is that there's mostly a practical thing on the safety side. So what you see is that these models produce an output for a certain input, but we as humans, we are rather stable in a sense that we do make mistakes, but we don't make completely unpredictable mistakes, right? If I ask you what 2 plus 2 is, this is not a question you would make an error to. But that is because we have such highly tuned learning algorithms in our brain, right? We are a product of such a long evolutionary history. These models also make errors, but they can be way more unpredictable compared to us. So these models might do very well the first 10 or 20 times, and then suddenly on a pretty basic question, it just hits the wrong way. And you can hardly ever predict when this will happen. And we can also not check it because there are so many possible questions and so many possible answers that we cannot all fully verify them. So by far the biggest thing about safety is that you should always be aware that on any answer you get or any response you get, you should always check. Because in the end, you're sort of responsible for this output. And that you are aware that if it worked 20 times, this gives you zero guarantees for the 21st time that it will also be correct. So I think this is big lesson number one. Yeah, and I think lesson number two is that we will never fully eliminate these mistakes, just as we are also not fully eliminating them in humans. So we, for
Okay.
example, also take driver's licenses for humans to do driving, but then afterwards we also make a mistake sometimes. We will move towards the same kind of thing with AI, where we start to do testing, and when we fall below a certain error rate, for example, below humans, we will start accepting this technology in certain applications, but it will never be completely flawless. There's no deep intrinsic intelligence that is infallible. That's definitely not the case. These models are obtained, and also not how they will work or will ever work, probably. Does that
Okay.
make sense?
Yeah, yeah. Okay, thank you so much.
Thank you. Gopika?
So my question is regarding, I was reading a couple of, research articles on, how AI is more often than not very sycophantic, like very much, pleasing to the whoever is giving the prompt, that tendency. So do you think that is true? And so my next question is, if you do think so, like AI has that tendency more, uh, why do you think that is? And what can we do to move away from it and make it more, the answers more real and authentic?
Yeah, no, it's a good question. Yeah, so I think it's definitely true. And the problem is that the big companies that are producing the state of the art of AI, they are producing a product, and it's a product that you should like as a user. And what happens is that these models are fine-tuned with, well, actually also what I work on myself as for research. This is this reinforcement learning. So learning through reward and punishment. And what they are doing is, for example, if you use an LLM, sometimes it gives you two answer options, right? So you ask a question, for example, on ChatGPT, and then you get option one and you get option two, and it asks you which do you like better. And usually you click the one in which it's, for example, more polite, or it gives the answer you think it should be giving. Anyway, something like this. What you're actually doing is you're rewarding the model. This is just training data. So these companies they're asking you this because they want you to tell them what you like. So then in the background, they are fine-tuning these models with what users apparently like. And therefore, these models are gradually becoming more and more pleasing and friendly, and they always want to give you something more, and they go along with you, right? So if you convince them 5 times, at some point they will just go along with whatever you said. So they are very easy to bribe or to convince. And that's just because these companies have no incentive to sell any truth. They want a product that is used. So they fine tune this based on what users like. And they actually ask you to help them with that, with giving these different answer options and asking them to tell you what you like. So I think this is definitely a problem. It has also already overshot. So at some point, these models were so pleasing that it became so annoying that they were actually not used anymore. So these companies are continuously balancing this thing of, I want my users to like it, but it should not become so grave and excessive that they start to completely distrust it. Um, but I do think the bigger problem underneath this is that the big forefront AI is produced by commercial companies with a money incentive, right? No one is pushing for a ground truth model in any way. They're pushing for a product that people want to use, and that's a different thing, right? There's some stress there between these two. So it's, I think, one, completely true, and two, it's, I think, not something that will be completely solved in the current system, where forefront AI comes out of large commercial companies. Is that answering your question?
Yes, thank you.
Thank you so much, Professor Merland. Intisar, you can ask your question, and it will be the last question, right?
So hello everybody. I want to thank you first for your informative and interesting presentation, especially that you talked more about deep learning. I want to start first with a recommendation because I know that we come from many fields and there are some people who doesn't actually teach or learn deep learning. It's a book from big researchers that actually called The Godfather of AI. It's Jeffrey Hinton, and he wrote a very excellent book that called Neural Network Architectures for Artificial Intelligence. So I want to recommend this book to anyone who want to deepen their knowledge about this field. And I also have a question. In your opinion, since you talked more about deep learning, but at first I saw that you showed different perspectives of thinkers like Leibniz, and thinking about reasoning is calculating, and how did these experiences or researchers helped you to have your own opinion about this? And I also want to know, how do you think that AI can improve the knowledge of people, of students, especially in education, without a negative impact on their critical thinking, for example.
So I did not fully understand your first question in the sense that you say there is different branches within AI, such as the reasoning, the classic scheme, and the more deep learning scheme. And do you
Yeah.
mean like where my critical view is in this space of what I think is the right path, or is that not your question?
I have noticed that you more talked about deep learning and machine learning. And
Yeah,
at
yeah.
first, you show different perspectives, like Leibniz, who's actually a mathematician and talks about more calculating, or Aristotle that insists on logic things. So I just want to know, how did you build your own or your main idea about deep learning, and how did you say that, for example, these experience of these researchers will help me build my own opinion about this topic?
Yeah, so the main message I try to convey is that this classic AI based on logic and sort of symbolic reasoning, it just got stuck. It essentially completely failed. And that's something, well, yeah, is that an opinion? I think it's sort of also, you can see it in the history of AI and the investments, and also that the state of the art of AI is not building on this type of ID. So I think there is a proper argument sort of from empirical results that you see that the current technology fully builds on this idea of deep learning and these neural networks and this type of information processing that is at least inspired by our brain. So that's how I've always took the departure point of that one. There's only one example of intelligence in this world we know of, and that we are ourselves of advanced intelligence, right? And that's based on our brain. So I think it should be somehow related to what we are doing in our brain. That has always been my conviction. And two, I think that the current results you see in AI, right, what these language models are doing, I'm not saying it's human level intelligence. There's a lot of problems with it, but at least the emergent properties you see are of such a quality that I think there must be some truth hiding in this path, right? You don't get these results completely out of nothing. So we looked at our brain, we took inspiration, we built something inspired by the computers, and it starts to give the answers that it's given right now, and it starts to show the properties it's giving right now. I think it's hard to ignore that we should be somehow in a path there, in a path in the right direction. Not to say how much I might be hiding, right? But I do think there are some clear indications why the current deep learning path is at least a path to follow. That being said, I do think, as in research in general, there is a risk if everybody jumps on the same train. There's always some trade-off between exploring and doing new things and all running after each other. And in AI, we are all running after each other at this moment in the deep learning hype for the last 10 years. And I definitely agree with you that there might be a lot of, it's hard to position yourself in this field because if you only run with the big bunch, you might also be missing sort of the new next big ID. And this, you could worry a bit about this in AI. But for now, I do think the main path is for sure this deep learning path, which is showing all the promise it has been showing in recent days. But it's a bit to be seen whether there will be a next new big paradigm shift, right? We have pushed this ID to the max, but we're also hitting some barriers because we want to take the next step, but there seems to be some open question of what the next type of algorithmic steps should be. If that answers your question. And the other thing about education is, I think, a bit what I said before. I think the only way we can guard students against losing their ability to critical thinking, I think it's one societal effort that is not only on teachers, but actually, for example, also on parents at home, right? Because this is the same thing as preventing people to start smoking. So I think it's something we should ingrain in our whole society. And the second thing is that we should almost enforce students to still make the effort, and that's must be in our examination system. That feels a bit tough, but I think you should, whatever you do, you should be able to show it at an examination at the spot without any support tools. So I think the future of AI has to be in the fact that we will do way more testing, examination at the spot. Also for home assignments, we should have teachers that are asking their students to explain what they did, just to make sure that they are actually forced to understand what they did and they are forced to be able to explain it. And I think there's almost no way around this. And I have compared this before to, for example, the invention of the calculator, also in this blog. So the idea is that when the calculator was invented, that's also a small form of AI, right? The calculator, it lets you do subtraction and addition, and essentially that is a type of AI. And after that, we did not stop doing calculations. We first teach students how to calculate, then we test them for it on an exam without a calculator. And then once they can calculate, they can use a support tool. Now, it's the same thing with AI. We should see this as a supportive tool. You should first learn to code yourself, and then you can use AI for code. You should first learn to write your report yourself, and then you can maybe use supportive AI. But it can never be a replacement for the first time you need to learn it. So yeah, I think we will need some types of regulations like this.
Thank you so much for your answer. Thank
Okay.
you.
Thank you so much, Professor Merland. Thank you, students, for your participation. Thomas Merland, I would like to thank you and to say how much we appreciate your time and your explanations regarding the parallel between the computer intelligence and the human brain. I personally consider that a computational intelligence might not be the only way we conceive the human brain. And so obviously, especially when we are speaking about education, we could have also other streams to consider. But it was very interesting and very fascinating. And I would like to thank you very much for the clarity of the explanations. It was very, very convincing and we appreciate it a lot. Thank you so much.
Sure.
Students, it would be great to have you on board next on February the 17th. I think it is Tuesday. Please make sure that you will be able to ask the questions and that the questions are, I mean, this is what I want to say, the questions are open to all. Make sure that you are and you stand up to ask your questions, right? That's very important for stage 2 of the sim of action, right? Thank you so much. I will close the session for today. Again, maybe a round of applause for our Professor Thomas Merland for his presentation for today. Thank you.
Great. Thanks so much.
Thank you. Have a good one.
Thank you so much,
Bye,
sir.
students.
Thank you.
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 Thank you. Have a nice
Thank
day.
you.